Well, let's put our hands together. Welcome Peter Landon, who is Senior Director of Product Line Management at Nokia. And he's going to talk about, actually, the impact of coherent routing on network management. All right, Peter, take it away.
Thank you. Thanks very much. Yeah, I'm Peter Landon. I'm a PLM for NSP at Nokia. And I think the program title for this, I think, was Making Peace with Alien Wavelengths. And I like talking about alien wavelengths. I actually presented this before, and I had my first slide was a picture from, I don't know if you remember the Alien movie, where the alien's jumping out of the chest of the person on the table or whatever. And that was my first slide. But the marketing team was like, oh, maybe you want to tone that down a bit. So I've taken that out, but we're still going to talk about aliens. Now, why are we going to talk about them? Well, with the advent of 400ZR and coherent routing, it's really having a profound impact on how alien wavelengths behave in the network. So what we're going to go through, you may be familiar with alien wavelengths, maybe not. We'll go through a brief history of them, why we need to be concerned with 400ZR and how they impact the aliens. So first of all, what is it? So I'll just read it. Transparent transmission of coherent optical wavelengths over a third-party physical WDM infrastructure. So you may be more familiar with a third-party transponder over another line system. But either way, it's essentially goes back to the days of pre-disaggregation. So, you know, call it the good old days where you had a single vendor doing both your transponders and your line system. They were also they also provided the NMS, so it was simple to procure. But people started to notice that the transponders had a different life cycle than the line system. This is because the DSPs and the transponders would evolve more quickly than the line system. And it was also noticed that the transponders, the price point was a bit higher, which is probably correct given that the transponders perform that magic of converting your electrical into photonics. So operators said, well, wouldn't it be great if we could get the transponders from a different vendor? And so disaggregation came to be, and this is where the alien wavelength was born. And the reason is because the endpoints where the parameters are provisioned into the optical transponder are separate from a different vendor from the line system. So the line system, you set up an optical channel, and it doesn't know anything about what's going over the optical channel. So a lot of the PMs and the management of that wavelength are impossible. So when we now introduce coherent routing, 400ZR, I'm from Canada, I call it ZR. My friends in the US call it ZR. So I'm going to sprinkle them in the presentation so I don't offend anybody. So this is just now showing the routers. You've got your gray optics and your typical transponder interface. Now with 400ZR, the transponder we were talking about is gone. So this is great. You know, you've simplified your network, maybe had some savings in the process, but there's a hitch. So now, not only are you provisioning, you know, from different NMS vendors, but you're actually in a different platform. Now you're provisioning optical parameters in the IP domain. So it's the IP team now has to set these parameters. And even if you're, you know, even if you have an NMS and your equipment from a single vendor, the IP team still has to take those parameters and provision them into the optical element that's now living in the IP domain. Even with workflows, you know, a manual process always is more error prone. Now, we have customers that are doing this because it's a good way to get started, and with a handful of channels, it's doable. But a much more robust architecture is to utilize what's becoming a de facto standard now between IP and optical controllers is the TAPI interface. And utilizing the TAPI interface, you can now have the IP controller, in this case NSP, provision a 400ZR service and gathering all of the important parameters like launch power and center frequency and modulation from the optical controller and have that wavelength provisioned with all of the correct information. This also does help with both third-party optical and third-party IP, because you can have a centralized management system to handle both. So what are the advantages of this non-alien architecture or managed architecture? Well, we don't anticipate operators ripping out all their transponders and replacing them with 400ZR pluggables. That's not going to happen. It's more likely that they're going to start to integrate these 400ZR pluggables into their network where they make sense, where they're applicable. And to do that, you want to be able to maintain all of your processes and all of your tools that you use currently for your optical provisioning. So this architecture allows you to maintain the tools and that infrastructure. It allows you to preserve the planning in this hybrid model. So it allows you to keep all of your planning tools that you would use in the optical domain as well, to ensure that you've got an optimal spectrum utilization. Power management, with the advent of 0 dBm pluggables, and even the 400ZR or 400ZR DCOs, power management becomes very important. It's not just a matter of turning the pluggable on. You want to manage that power in an automated control loop. So this architecture allows for that. Management and troubleshooting is also very important. Having a unified topology map that includes your IP domain as well as the optical domain, and automatically detecting the connections between them is paramount to reducing your troubleshooting time. Adding wavelengths to new wavelengths to an existing DWDM system also requires some potentially some planning and to avoid disruption of existing wavelengths. You might implement a power amp, but that is possible in this architecture. And because the IP system understands, or the IP controller understands the parameters of the plug, the modulation, and therefore potentially the reach, it can make better path placement decisions. It allows you, because again of knowledge of from the planning tool, you can make the correct decisions on channel center frequency and align to your to the grid that exists. Performance guarantees. So if you've got quality of service or SLAs in place with a coordinated management architecture, you can maintain those. An example would be diversity analysis. So having knowledge of the underlying SRLGs allow you to make foolproof diversity path placement. And we actually have a demo of that at our Nokia booth, if you want to see it. Link adjacency discovery, if you're familiar with LLDP snooping, this allows you to automate the discovery of connections, your gray optic connections between IP and optical, between your router and your transponder, for example. Well, with 400ZR, you don't have that gray optic anymore. So you're connecting directly from a pluggable into potentially a ROADM or a FODEM infrastructure. So having an automated way to do that discovery is very important. You want to be able to maintain an accurate topology. Alarm correlation, so having a single pane of glass for all of your alarms, both IP and optical, allows you to not only simplify troubleshooting, but you can actually bring in elements of root cause analysis and have automated ways to determine from a flood of, for example, IP alarms, which optical port are these all pointing to. And so, again, ease of troubleshooting. And this last one, roles and responsibilities, we don't talk about it really in the larger forums, although my colleague Heidi did this morning a little bit. But we know that many organizations have silos, IP silo, optical silo, and when you start talking about roles and responsibilities, who does what, it can get tricky. So you want to have an architecture that allows a cooperation and enhanced efficiency in when you're having those conversations and some sharing of tools between the two groups. So another benefit is with the architecture, you can implement intent-based provisioning. And if you're not familiar with intents, it's essentially using an intent to configure what you want, not how you're going to do it. And it allows you to maintain a single source of truth in the NMS, so that if something happens, for example, in the middle of the night, somebody goes in and does a CLI command on a node, if you go in the morning, you'll see that a particular intent is out of alignment. It'll allow, so you quickly have that knowledge. You can go in and look at what was changed and decide to realign that single node, or if you like the change, you could actually pull it into your golden template. So this will become important as the 400ZR connections proliferate and become more widely deployed. So a slide on the complexities of IP optical management, and really I see it as a gradient where on the starting on the left you've got a 400 gig gray optic pluggable between your IP node and other IP node or transponder perhaps. In this case it's pretty simple, the link is up or down. For 400ZR unamplified, again pretty simple, you're just looking at the link status. As soon as you start bringing in optical components in an amplified case, for the application one for 400ZR, then you start looking at channel plan and perhaps a power amp. It gets a bit more complex, and you still have to obviously look at the link status. When you get into multi-hall, which is the DCO or a 0 dBm pluggable, then obviously power management and a power management algorithm becomes very important. The magenta, you bring in ROADMs into this infrastructure. You may start to need dynamic gain equalization. And then lastly, in a full hybrid solution with 400ZR transponders, ROADMs, for this you're going to need to do all of it, plus also perhaps have a PCE element as well. So the main takeaway here is that 400ZR is really going to have a profound impact on the way the networks are managed. And having this cross-domain coordination between the IP and the optical is becoming very important. It's going to allow operators to have some CapEx savings, optimize their network, but also maintain their quality of service and have a scalable solution. Thanks very much.
Hello, this is Plinio from Patec. I have a question regarding your support for 400ZR+. Are you promoting like the more style OpenZR Plus or open ROADM ports like with OTN like OEM style for mapping for the operations team that is used to transponders, for example? Which kind of port are you promoting? The open ROADM pluggables or the 400ZR OpenZR Plus?
Are you referring to Nokia, you mean? Or
yeah.
We're supporting the 400ZR, and but we also, we also work with the Open ROADM standard as well, and that would be more probably on the transponder port side.
Okay, and for that mapping that you're saying for the operations team that are used, for example, for transponders, you're mapping for some OEM from the Ethernet, for example, Ethernet style to a more traditional transponder OEM, or you're doing this mapping to show to this team?
You're talking management?
Yeah, in terms of OEM for the management and monitoring, how this mapping, could you comment a little bit on the mapping?
Oh, okay, you're talking about alarm correlation.
Or something, yeah, for monitoring, for FEC or something. How are you doing this mapping? once you take out the OTN layer, for example, from these ports, how do you do this mapping?
So in our case, we've got optical service objects that have, in the optical domain, a set of correlation rules. So if there's particular alarms that are related to a particular service type object, they get correlated in the optical domain. Same thing happens in the the IP domain. We've got correlation rules between different IP alarms. And then within our cross-domain coordinator application, we coordinate between those two domains with another set of correlation rules. So the end result is an IP alarm, for example, would have a root cause analysis button that would utilize the correlation rules to pinpoint which optical correlation rule is pointed to, and ultimately the port or object that's at fault. Yeah.